Across the United States, there are places often called the graveyards of aviation. Here, thousands of aircraft that once crossed the skies now sit motionless after their final flight. At first glance, they may look like giant pieces of scrap metal waiting to be discarded, but the reality is very different. A Boeing 747 could cost up to $400 million when new and, over its lifetime, fly more than 40 million kilometers, equivalent to over 1,000 trips around the Earth. That is why these aircraft still hold enormous value even after retirement. Instead of being thrown away, they enter a carefully controlled industrial process. Engines, avionics, aluminum alloys, titanium, and thousands of other components are removed, sorted, and recovered for future use. So what really happens inside these massive aircraft storage facilities? Let's find out with Mandarin Tech. According to international aviation statistics, the United States operates thousands of commercial and military aircraft each year, accounting for about 30% of all active aircraft worldwide. It is also home to Boeing, one of the largest aircraft manufacturers on the planet. For decades, the competition between America's Boeing and Europe's Airbus has fueled a trillion-dollar technology race, continuously pushing aircraft production and operations to new records. Each year, more than 600 commercial aircraft are retired after reaching the end of their service lives and no longer meeting aviation safety standards. They are then sent to the Boneyard, the world's largest aircraft storage facility in Tucson, Arizona. For many of these aircraft, this is also the destination of their final flight after decades of service. Upon arrival, they undergo comprehensive inspection and evaluation by specialists to identify valuable components that can continue serving the aviation industry before the remaining structure is placed into storage or dismantled. Before it can become a source of materials worth millions of dollars, an aircraft must undergo a comprehensive decommissioning process to ensure safety. Depending on its size, a commercial aircraft can carry up to 180,000 liters of jet fuel in tanks located inside the wings and fuselage. Even after its final landing, a certain amount of fuel always remains in the system. To eliminate this risk, technicians connect specialized industrial pumping systems to the fueling ports and remove any remaining fuel. The recovered liquid is transferred to sealed storage tanks, where it is inspected, filtered, and reused for industrial purposes rather than being discarded. Once the fuel has been removed, the dismantling process begins with the most accessible external components. Wheels weighing hundreds of kilograms are removed, inspected, and stored separately. Passenger doors, cargo doors, and various access panels are then taken off one by one. Many of these parts can later be reused as spare components for the aviation industry. The next stage focuses on the cockpit, which contains hundreds of sophisticated electronic systems worth more than $10 million in total. For this reason, it is always one of the most carefully handled areas before the aircraft is dismantled. Technicians begin by removing critical electronic systems, such as flight computers, navigation equipment, and communication systems. Each component is labeled, assigned an identification number, and sent to specialized inspection centers. After recertification, many of these devices can continue operating on other aircraft or serve as spare parts for the aviation industry. Beneath the instrument panel lies a network of electrical wiring, data cables, and sensors running throughout the aircraft, with a total length ranging from 150 to more than 300 kilometers, depending on the model. These systems are removed section by section to recover reusable sensors, connectors, and electronic modules. Once the last valuable components have been recovered, the area that once controlled a machine weighing hundreds of tons in the sky is reduced to an empty structural shell. Technicians use industrial saws, hydraulic cutting equipment, and sometimes plasma cutters to separate the aircraft nose from the main fuselage. Depending on the aircraft type, the nose section alone can measure from 5 to more than 10 meters in length and weigh several tons. Heavy forklifts or specialized cranes then move the entire structure to a material sorting area where aluminum, titanium, composite materials, and many other components continue to be recovered before the remaining structure is recycled. For many modern commercial aircraft, A single jet engine can be worth more than $30 million. Even after an aircraft reaches the end of its service life, the engines are often its most valuable components. As a result, they are usually among the first items to be recovered. The removal process is far from simple. Each engine can weigh anywhere from 4 to more than 10 tons. Before work begins, cranes and specialized lifting frames are positioned and attached to designated lifting points on the engine. Meanwhile, technicians remove structural bolts, piping systems, and control connections linking the engine to the wing. Every step is carried out slowly and with great precision. Even a small mistake can damage components worth millions of dollars. Once the final connections have been removed, the entire engine is carefully lowered onto a specialized transport stand and sent to inspection facilities. There, the engine is further disassembled into major sections, such as the fan, compressor, combustor, and turbine, so that each component can be evaluated. Parts that still meet technical standards are cleaned, repaired, or overhauled before returning to service on other aircraft. Inside the aircraft, the cabin that once carried hundreds of passengers has now become a massive dismantling site. This is one of the most time-consuming stages of the entire process, as almost everything inside can be reused or recycled. For that reason, before any heavy cutting equipment is brought in, the entire interior must be removed manually in a careful and systematic manner. Passenger seats are usually among the first items to be removed. Each seat is detached from the floor, inspected and sorted individually. Many seats remain in good enough condition to be refurbished and reused or serve as spare parts for the aviation industry. Overhead luggage bins, cabin partitions, galley equipment, lavatories, lighting systems, and many other passenger service components are then taken out one by one. Each item is labeled and moved to storage areas for evaluation and potential reuse. Even soundproofing materials, carpeting, and interior panels are carefully removed and set aside for recycling. After days of continuous work, the space that once carried hundreds of passengers gradually becomes empty, revealing the aircraft's massive metal framework. At this stage, all that remains is the aircraft's massive structural framework. Most valuable components have already been recovered, revealing a complex structure made up of thousands of frames, load-bearing beams, and aerospace-grade alloy panels held together by millions of rivets. Heavy-tracked excavators fitted with specialized hydraulic shears begin moving in. Depending on the model, these attachments can generate cutting forces of several hundred tons. As the steel jaws close, they not only slice through the outer aluminum skin, but also crush the reinforcement beams and structural frames hidden deep inside. With every cut, a section of the aircraft structure, originally designed to withstand enormous stresses during flight, is torn apart. The process usually begins with the tail section. The vertical and horizontal stabilizers are large structures, but are relatively easy to access. Excavators cut through the main connection points and break the entire assembly away from the fuselage. Metal sections several meters long are lowered to the ground and then cut into smaller pieces. At many dismantling facilities, these components are not kept intact, but are processed immediately on site to reduce their size and make transportation easier. Aircraft wings present an even greater challenge. On wide-body aircraft, each wing can extend more than 30 meters in length and contains large amounts of aerospace-grade aluminum, along with extremely strong load-bearing structures. Rather than making a single cut, excavators must constantly reposition themselves, cutting gradually from the wingtip toward the wing root. Sections of the structure are bent, twisted, and crushed under the enormous force of the hydraulic shears. Even the main structural spars, originally designed to support tens of tons of load during takeoff, are eventually cut apart and divided into smaller sections. Once all protruding structures have been removed, the fuselage becomes the final target. The aircraft body is not simply cut in half. Instead, it is divided into separate sections. Each section, several meters long, is detached from the main structure and then further reduced in size. Hydraulic shears continuously crush, tear, and cut through layer after layer of metal, turning large fuselage sections into pieces ranging from a few dozen centimeters to several meters in size. This process is repeated hundreds of times. Every cut produces more pieces of aluminum alloy, titanium, and high-strength steel size for transportation. Wheel loaders continuously collect material from the demolition area and load it into dump trucks waiting nearby. One truck after another leaves the dismantling site, carrying what remains of the aircraft to specialized material processing facilities. For wide-body aircraft, the total amount of recovered material can exceed 100 tons. In just a few days, an aircraft tens of meters long and once responsible for thousands of flights gradually disappears from the dismantling yard. Inside the trucks leaving the dismantling yard are tens of tons of high-quality aerospace materials, with aluminum alloy making up the largest share of the recovered weight. These aluminum fragments are transported to specialized metal processing facilities, where their journey of rebirth begins. There, the material is first shredded into pieces only a few centimeters in size to improve processing efficiency. It is then fed into large melting furnaces operating at temperatures of around 700 to 800 degrees Celsius. During this process, fluxing agents are added to bind with impurities and bring them to the surface in the form of slag, helping the metal reach the required level of purity. Once refining is complete, the molten aluminum is poured into continuous casting systems to produce new billets or ingots. These products are then rolled into sheets, coils, or bars for use in a wide range of industries. For the recycling industry, aircraft aluminum is considered an especially valuable raw material because of its high alloy quality. In addition, recycling aluminum requires only a fraction of the energy needed to produce new aluminum from bauxite ore, significantly reducing both costs and environmental emissions. Although steel does not make up as large a share of an aircraft as aluminum alloy, it is still used in many critical load-bearing components. Recovered steel fragments are processed through industrial shredders and then transported to electric arc furnaces. There, massive crane-mounted grab buckets begin feeding tons of scrap steel into the furnace. As giant graphite electrodes are lowered, a powerful electric current creates an arc with temperatures exceeding 2,000 degrees Celsius. Within a short time, the solid metal pieces glow red-hot before gradually melting completely. Once the required specifications are achieved, the molten steel is poured into continuous casting systems to form long steel billets. These billets then pass through hot rolling mills, where they are compressed and stretched repeatedly between high-speed rotating rollers. The final result is steel products manufactured to standard dimensions. Alongside steel, the aircraft's electrical wiring system is also a valuable source of recyclable material. After removal, bundles of wire are sent to specialized shredding and separation lines. High-speed rotating blades cut through the outer insulation, while automated separation systems remove the plastic coating from the metal core. The recovered copper is then thoroughly cleaned to remove impurities before being sent to melting furnaces. Under high temperatures, the copper becomes molten and is cast into new copper wire. Thanks to its excellent electrical and thermal conductivity, recycled copper remains in high demand. After processing, it may be used in electrical wiring for residential and commercial buildings. Other portions are used in power transmission systems, where the conductors continuously deliver electricity to communities and industrial facilities. However, not every aircraft ends its journey in a recycling facility. A select few are given the opportunity to begin an entirely new chapter. Aircraft that hold historical significance, set records, or represent major milestones in aviation are often acquired and restored by museums. After months or even years of repair and restoration work, they are returned to their most iconic appearance and placed on public display. Although they no longer fly, these aircraft continue to tell the story of a remarkable era in aviation history. Meanwhile, many other retired aircraft are transformed into unique structures on the ground. Once unnecessary technical systems have been removed, passenger cabins are converted into restaurants, cafes, hotels, or event venues. The cockpit is often preserved as a special feature, offering an experience that conventional buildings cannot easily replicate. From machines that once traveled millions of kilometers through the skies, they continue to attract people in an entirely different way. From a machine that once connected continents, an aircraft does not simply disappear after its final flight. Instead, it is reborn in many different forms and continues its journey through an entirely new life cycle. And who knows? A piece of an aircraft that crossed oceans today may one day become part of a building, a vehicle, or even a brand new aircraft of the future. Do you think retired aircraft should be completely recycled, or should some of them be preserved as part of our aviation heritage? Share your thoughts in the comments below. And don't forget to subscribe to Mandarin Tech for more stories about technology, engineering, and the world's most incredible mega projects.